Hey everybody, welcome to Unit 3, Day 6, Explicit Formulas. Your learning targets state you'll be able to write the explicit formula for a sequence and use the formula to identify terms in the sequence. You'll be able to read and write explicit formulas with subscript and superscript notation. And finally, you'll be able to find terms of a sequence that's given explicitly. So first off, we have a definition here. An explicit formula gives a direct relationship between two discrete quantities. It defines the nth term in relation to n rather than the previous term. And we talked about this when we had arithmetic sequences. Arithmetic sequences, just like geometric sequences that are recursive, rely on the previous term. But an explicit formula for geometric or arithmetic does not necessarily rely on a previous term. So when we had our arithmetic, we had a u sub 1, so we had a starting point, equals our u sub n minus 1, our previous term, plus or minus something. And when we went to an explicit, we had whatever we were adding times the n, so whatever we're going up by, that was the slope, times the n plus our starting term. Okay, so geometric is going to be somewhat similar to this. But first, let's take a look and see if we can figure out what the exact pattern is. So we have this geometric sequence here, u sub 0 equals 4, and u sub n equals u sub n minus 1 times 2. So I want you to take a minute, pause the video, write out how you get each term, and can you find a pattern? Welcome back. Let's take a look and see if you found the pattern. U sub 0 is 4, u sub 1 is 8, u sub 2 is 16, u sub 3 is 32. So of course they're doubling. But what you have here, let's see if I can get my bigger eraser here. You have 4 times 2. And here you have 4 times 4. And here you have 4 times 8. But let's think about another way to write 4. We can say that that's the same thing as 2 squared. And this one, I don't think I put one there. And this one we can write 8 as 2 to the third. So looking a little bit closer here, this would be 4 times 2 to the first power, 4 times 2 to the second power, 4 times 2 to the third power. So taking a look at where we started with a 4, and we're doubling, starting with a 4, doubling, and then we've got this exponent here. Notice that it matches up here. We might be onto something. So here is our formula. This is what's really happening. In a geometric explicit formula, this is your nth term. This is your initial or starting value. So this is where you start. This is your common ratio. You can also think of it as your growth or your decay rate. And this is the term number. And sometimes this is going to be in time, like months or weeks or years or days. Okay, so another way to think of it, u sub n equals u sub 0 times your ratio to the nth power. So take a minute, pause the video, write that down, put that in your notes, get it where you're not going to forget it, okay? All right, moving on. Here is an example. Notice that we have a u sub 0 here. That's 60, and u sub n is 0.8 times our previous term. Now, since this is less than 1, that means that our pattern will be decreasing here, okay? So pause the video and see if you can figure out what the explicit formula is, and also see if you can figure out the 10th term. All right, welcome back. This is what your explicit formula should have been. You should have had 60 times 0.8 to the n. Your starting amount times your growth or decay rate to the nth power. Finding your 10th term here, 60 times 8, 60 times 0.8 to the 10th gives you about 6.44. Let's try another one. Most of the time, we're going to give you the u sub 0, but like I've told you the whole unit, if you just have a list of numbers, this is going to be a u sub 1, okay? So this is a situation where we have to find the u sub 0. 15 to 30 to 60. If you can't see the pattern, take 30 divided by 15, take 60 divided by 30. each time it's just doubling. So to get our u sub 0, we're going to go the other way. We're going to divide. So our u sub 0 here is going to be 7.5. And our u sub n is 2 times the previous. So 2 times u sub n minus 1. Take a moment, see if you can figure out what the explicit formula is. Alright, so if you had 7.5 times 2 to the nth power, you got it right. This is your starting amount. There's your growth or decay rate to the nth power. The 12th term here, 7.5 times 2 to the 12th power, gives you about 30,720. All right, we are getting close to the end here. Let's do one more. And we've got Jackie here, and she deposited $500 into an investment that earns 4.2% annual interest compounded annually. So because it's compounded annually, we're not going to have to divide by anything, okay? Writing a recursive formula. Take a moment, give that a try. Your recursive formula, u sub n, u sub 0 is 500, and u sub n is u sub n minus 1 times our 1.042, or 1.042 u sub n minus 1. So, take a minute, see if you can write the explicit formula. Here's your explicit formula. U sub n is going to be 500, our starting amount, times 1 plus 0.042 to the nth power. And then the value of the investment after 3 years, the only thing that we change here is we change this n to a 3. When you do that, you get approximately $565.68. So that's pretty good for not adding any more money to that account, just relying on the interest there. All right, that's all I've got for you for today. What I need you to do is I need you to work on assignment number worksheet 6 in your packet, and we will see you later.